Hi again, everybody. Now we're on number 49 on page 280, again, chapter 8. The averages of several measurements are less variable than individual measurements. We just went over that in the previous example. The true mass of the whiskey sample in exercise 47 is 4.6 grams or 4,600 milligrams. Antonio's measurements have a normal distribution with a mean of 4,600 milligrams. The standard deviation is 10 milligrams. In this case, the mean of his three measurements also has a normal distribution. Part A, sketch on the same graph the two normal curves for individual measurements and for the means of the measurements. Figure A10 is an example of this kind of graph. Part B, what spread of values covers the middle 95% of Antonio's measurements? Part C, what spread of values covers the middle 95% averages of the three measurements? In this problem, I'm going to use the book solution because, of course, as you know, I'm not the greatest artist. And they have a really nice picture here. So I'm going to zoom out a little bit. Maybe I'll zoom out. There we go. Okay. Now, this curve is the one-time measurement. Again, we have a mean of 4,600. In this problem, the standard deviation is 10. So when I go one standard deviation to the right and one standard deviation to the left, I find out that my 68% would be from 4,590 to 4,610. We're asked to find the 95% range, so we want to go two standard deviations away from the mean. And if I go two standard deviations away from the mean, I will have 4,600 minus 2 times 10, which is 4,580. I go two standard deviations the other way, I have 4,600 plus 20, 4,620. Again, that is for this one. Now keep in mind your curvature points, you'll notice that it's kind of concave down here, and then it changes to concave up here. That change will take place here at that point where this first standard deviation is. Something to remember from earlier in the year. Part C says now use the 5.77 from when you took the three measurements, and you can see how our normal curve changes. We still have 4,600 as our mean. However, when I go one standard deviation away and one standard deviation away to both sides, my new values will be closer to the mean. So if I take 2 times 5.77, I will get 4,588.46. If I add it, I will get 4,611.54. So that will be my 95% range for my three measurements. Any more questions, just let me know.